Hi! Today, we will learn about inverse variation. For our objectives, first, illustrate situations that involve inverse variation, translate into variation statement a relationship involving inverse variation between two quantities given a table of values, a mathematical equation, a graph, and vice versa, and solve problems involving inverse variation. So what is inverse variation? Inverse variation occurs whenever a situation produces pairs of numbers whose product is constant. The statements y varies inversely as x, y is inversely proportional to x, may be translated mathematically as y is equal to k over x, wherein k is the constant of variation. This means that as x increases, y decreases, and if x decreases, y increases, and the product between them always stays the same. Here are some situations that describe inverse variation. As the number of workers increases, the time to complete the task reduces. As the speed goes down, the travel time goes up. Other examples are, let's say for example, in a family. The greater the number of family members, or as the number of family members increases, the duration of time that the food supply will last decreases. Or as the number of family members decreases, the duration of time that the food supply will last increases. So how do we translate variation statement into a mathematical equation? Say for example, the force needed to break a board varies inversely with the length of the board. That is, F is equal to K over L, where K is equal to the product of F and L, where K is the constant of variation. Another one, the time taken to spread landscaping rock varies inversely as the number of people working. In mathematical equation, that is T is equal to K over N, where K is equal to Tn, where K is the constant of variation. Let's have some examples. If y varies inversely as x and y is 10 when x is 6, find the constant of variation and the equation of the variation. So first, we will translate this statement into a mathematical equation. Y varies inversely as x. So that is y is equal to k over x, where k again is the constant of variation. It says in the problem that y is 10 when x is 6. So let us substitute 10 for y and then 6 for x. After that, cross multiply, k is equal to 60. This is now our constant of variation. Since we now have our constant of variation, we can now write the equation of the variation. We simply substitute the value of k in the equation y is equal to k over x. Therefore, the equation of the variation is y is equal to 60 over x. Let's have another example. The table below shows that the length of a rectangular field varies inversely as its width. Find the constant of variation and the equation which describes the relation. Observe each pair of values. Multiplying x and y in all pair of values will give a product of 120. We have here 2 times 60 that's 120. 5 times 24, that's 120. 8 times 15 is also 120. And 15 times 8, that's also 120. Therefore, the constant of variation is 120. And since the length varies inversely as the width, then we can say that L is equal to K over W. And since K is 120, therefore the equation of the variation is L is equal to 120 all over W. This is now the equation of the variation. Let's have example number 3. Suppose y varies inversely as x and y is equal to 30 when x is equal to 3. Find the value of x if y is 15. So first thing that we need to do is to translate this statement into a mathematical equation. Y varies inversely as x, so that is written as y is equal to k over x. Y is 30 when x is 3. Let us substitute 30 to y and then 3 to x. So that will be 30 is equal to k over 3. After that, cross multiply in order to solve for k. Therefore, k is equal to 30 times 3, that will give us 90. 90 now is the constant of variation. Since the constant of variation is 90, we can now write the equation of the variation. Substitute 90 to k. So we have y is equal to 90 over x. Next, find the value of x if y is 15. So in order to solve for x when y is 15, using the equation, substitute 15 to y and then solve for x. Cross multiply. 15 times x is 15x. So this is 90. Now to solve for x, divide both sides by 15. Therefore, x is equal to 90 divided by 15, that will give us 6. Therefore, if y is 15, x is equal to 6. Let's have another one. In a factory, 10 men can do a job in 30 days. How many days will it take if 20 men do the same job? Since as the number of workers increases, the number of days that it will take them to finish the job decreases. So we can say that this problem involves inverse variation. So let us first substitute a variable that will represent the number of workers. So let's say we use m for the number of men or workers, and then d for the number of days that will take them to finish the job. So it says in the problem, so if the number of men varies inversely as the number of days, we can translate that into a mathematical equation. M is equal to K over D. 10 men can do a job in 30 days. So if M is 10, D is 30. Solve for the constant of variation. K is equal to 10 times 30, 300. The equation now of the variation becomes M is equal to 300 all over D. How many days will it take 20 men do the same job? So if M is 20, what is D? So we have 20 is equal to 300 over D. cross multiply, we now have 20D is equal to 300. Solve for D, divide both sides by 20. Therefore, D is equal to 300 divided by 20, that will give us 15. So it only means that 20 men can do the same job in 15 days. So that is how we illustrate situations that involve inverse variation. Translate into variation statement a relationship involving inverse variation between two quantities given by a table of values, a mathematical equation, and a graph, and vice versa. And that is also how we solve problems involving inverse variations. Thank you very much.